Hi there. In this screencast, I'm going to go through factoring a trinomial, a complex trinomial. And while I do it, I'm going to point out some of the mistakes I see people making as they go through this process. First of all, let's be really clear on what factoring is. Factoring is it's taking a number or polynomial, say, and reducing it to a product of factors. And usually when we're trying to get is at like the base factors, like the prime factors, or things that can't be factored anymore. So for instance, 18, we could factor it and say it's 2 times 9, but even better, we'd say it's 2 times 3 times 3, or 2 times 3 squared. Or another example would be like 7n squared plus 104n. Oops. The greatest common factor in this is n, so we could factor this to n times 7n plus 104. So when we factor 18, we get this. When we factor 7n squared plus 104n, we get that. So today's video, though, is about doing this guy here. So first step is we've talked about a lot. We want to find two numbers when multiplied equals something and when added equals something. So the first mistake I've seen people make quite a few times is they go, well, I'm looking for two numbers that multiply to negative 15 and add to 104. And that would be incorrect. In a complex trinomial, we want two numbers that multiply to 7 times negative 15, which I believe is negative 105. Yeah. Okay, so we can move forward with this then. So we're looking for two numbers, negative 105 and sum to 104. So maybe our first guess would be, I don't know, like just wild guess, you'd say maybe negative 5 and, I mean, we know that, I think we know this isn't it, but negative 5 and 21. Those sum up to be 16. So that's not really going to work for us. We need numbers that are much further apart. And I can see that 105 and 104 are really close together. They're only off by 1. And that tells me that actually the numbers I'm looking for are 105 times negative 1. And that'll give us 104. Okay, so we know these two numbers that we're looking for. And what we can do is we can rewrite this polynomial or trinomial using these numbers instead. So I could go 7n squared plus 105n minus 1n minus 15. Okay, the next step I've seen people do is they go, well, we're going to factor this into two binomials. So they go 7n squared plus 105n negative 1n minus 15. This is incorrect. It's not a multiplication in there. That's not correct. We can't lose track of this of the actual operation. There are two ways to write this out correctly. The first way would be splitting into two binomials like this. So 7n squared plus 105n, and then we'd say plus, minus 1n plus 15. And we have to be careful when we do the minuses. So if we were to distribute this minus sign inside, you get negative 1 times n is a negative n, negative 1 is negative 15, and we can see that that and that are the same. So that works out. That's one way to write it out. The other way to write it out is I've seen some students go 7n squared plus 105n plus negative n minus 15. And that's correct too. So both those are okay. The second way though can lead to some tricky stuff. So I'm going to go through that as the next sort of mistake or problem that some students will have. So they'll go, okay, well I can, in this binomial I can factor out the 7n. So 7n leaves us with n plus 15. And this one, it doesn't factor out anymore. We're kind of stuck with negative n minus 15. And this appears to be a problem. It looks like we can't factor this anymore. This is not a common term. This is different. There's two binomials, two binomials, and they have a different common term. But there is a way around it. We could rewrite this as 7n n plus 15. That's fine. If we change the sign of this one to a negative 1, we then change the sign of the factors inside to n plus 15. And now you can see we can move ahead. That and that are a common factor. So we can treat that as a common factor that can be factored out. So we could say n plus 15 times, okay, so n plus 15 times something gives us this, so that's a 7n. And n 15 times something gives us this, that's a minus 1. And there you have it. That's the final solution in factored form.